Hello and welcome to this overview on how to build a nitrogen-filled computer. Hey, well, what's this tank of water for? Are you sure you just want to be doing that? Hey, I'm just kidding, guys. This computer is meant to go underwater. It's completely pressurized. It's called the Natick Mini, and it's inspired by the special projects team at Microsoft. They built a submersible data center that spent 2 years underwater, and it was developed by Spencer Fowers and Ben Cutler and the special projects team over at Microsoft. And when I read about that, I was just so inspired that I wanted to try to do sort of my own version, but a lot smaller. I wanted to see, could those same principles that made that project possible be applied at a much smaller scale, even to be a personal computer. Because nitrogen has some really interesting properties. It's an inert gas, and it doesn't interact with electronics in the same way that normal air does. You can actually extend the lifespan. What they found in the Natick study was that you can extend the lifespan and improve the reliability of the computers in this nitrogen environment. And so that was just so fascinating that I got to work and I drew up some plans and I started approaching various companies to sponsor this project. Well, long story short, it was just such a pipe dream that nobody wanted to do it. But I was like, hey, you know what? Let's just do this thing. So I spent a couple $1,000s just buying parts, and I wanted to share sort of everything that was involved in this process with you through this video. So this footage will be playing back at about 6 times speed. You can see I've got a 1/4-inch sheet of aluminum, and I'm drilling into it to make some holders. What I did buy is a oil pan for a Ford F-250. And then this is just a sheet of aluminum, and I'm going to put a gasket in between there. Drilling these holes would have been a lot easier with some oil, but if you want to know more about this project, feel free to reach out to me. One thing that was really cool was that the special projects team ended up kind of corresponding with me a couple times throughout this project and sent me a t-shirt as sort of a, hey, good job, Andrew, way to go kind of thing. And I was just really encouraged by that. I'm not really super great at metal work, even though, yeah, I did manage in the end. All right, so we finished cutting the metal. Now I'm going to give you a little overview of the different parts we're going to use to assemble this and make it a pressurized tank. As you can see, we've taken our aluminum sheet, we've drilled the holes so it's ready to line up with our tank. Next, we'll be taking this silicone. We'll be trying to cut this accordingly to make a gasket. But then also we have a few other smaller fittings that I'll take you to come see here quick. All right. So here we've got a bulkhead, and this is a 1/4-inch inner diameter bulkhead that we will put with these rubber washers to make that airtight. Once we've got the bulkhead installed, next will come this 1/4-inch nipple fitting. That'll go in there. And from there, it'll go to this T-joint, also 1/4-inch. That'll go on top, probably like this actually. On top of that, we've got the measurement 0 to 60 psi pressure gauge. So that'll be telling us how our pressure is doing and making sure we aren't losing any. And we have lastly a tire valve, also 1/4-inch. And this tire valve will be able to fill it with automotive nitrogen, which is the plan. So that's the parts. We also have these M6 20mm bolts here with some nuts as well. So we're ready to go there. And we also got the Loctite 545 high pressure thread sealant. And this works especially good in high pressure environments, so the box says. And so later on, we've got some more things to show you. I'm really excited to tell you more about this and what this does. But for now, let's get busy. All right, let's do it. Let's get busy. So yeah, here I am just taking a little punch. I'm going to punch that metal so that the drill knows exactly where to go. I've got a really specific plan. At this point, I've already ordered the computer I'm going to use. We ended up using an Intel NUC, which is a small form factor PC that I measured to have it fit inside this case perfectly. The nice thing about the NUC is that it has really just, it only needs an input and an output. Basically it needs power in, and it's kind of got a USB-C connectivity so that you can just have all your ports running through that one wire. It also uses wireless internet, so I was like, oh, Well, my ports will be pretty easy to pass through. So I just drilled a little hole. And then here I am just threading through that sort of bulkhead piece with the washers. I loved this project. It was so much fun, and the best part about it was actually corresponding with the Microsoft Special Projects team. They were some of the coolest people I've ever met, and yeah, you know, these types of things can be expensive when you take it on yourself, but it was really fun to just dream along with the special projects team about what could the future be with nitrogen computers. Will there come a day where all computers are perhaps encased in nitrogen or other inert gases so that, you know, they don't corrode and they last a long time? It was just a really fun experiment in that. So here we are putting that Loctite on. This is all very experimental. I know I look like I know what I'm doing, and to be honest, I've been a tinkerer all my life, but this was very much a trial run, I guess you could say. Welcome to my garage. You can see it's in Minnesota where I live. Not the prettiest garage, but hey, lots of great things start in garages, right? Well, here we are just getting ready to seal that up, and throughout this video there'll be times where I actually cut to the live audio from the video, and then you can hear what I'm saying. Here I'm basically just saying I'm, you know, putting this all together and it's looking about right. So there we go. Well, this is the part I've been looking forward to all day long. I've got my silicone rubber gasket cut and fit to size my tank, and I've got my pressure gauge and fill assembled. Isn't that cute? It's all ready to go. And in just a minute I'm going to tighten it down with these bolts, and we are going to see if this thing holds air. Looking back on it, cute probably wasn't the word to use. I was probably looking for more like super cool or high tech, but no, I guess I said cute. So I guess if you can compare this to the actual Natick, it is probably more on the cute end of things. The real Project Natick was such a huge undertaking, and you know, the combination of so many skilled research and development staff there at Microsoft that I felt like I was kind of building a
all right, here goes.
Small scale.
Got my safety goggles.
Here's the first pressure test.
Got my tank ready to try. And let's see if I can get 15 psi in here. 10 to 15. We did it. Yes, it's got 10 psi and it's holding. Oh wow.
I guess I didn't know what to expect.
Oh, this is exciting. Well, I better get some soapy bubbles and see if I have any leaks, or should I just leave it overnight? Let's check that gauge, get a little closer. It's at exactly 11. So, wow. This is exciting.
And I was super excited to get to this point. It was a lot of planning, and here I am just kind of looking at the parts now. So here's the Intel NUC, and I bought this USB-C hub that I would pass through one of those bulkheads eventually. But I just booted it up and everything seemed to be working, so I was making plans to move ahead to the next step, which did involve taking apart that NUC. You can see here I've got it disassembled, and I wanted to use these 1/4-inch heat pipes to draw the heat away from sort of the main heat pipes.
All
right. Sorry about the garbled audio there, but basically what I'm saying here is that we've got these,
so here's the point
these bulkheads.
No turning back. We're going to put this thermal glue on here, and I'm going to put some here.
Here we are applying that thermal glue. We'll come back to the bulkheads. You'll see what I'm talking about.
Adhere the board to the lid and provide the conductivity that we are looking for to transfer the heat pipe, what's in the heat pipe over. So we've measured this a bunch of times, and I think we're ready to set it on down now.
This actually took a lot of measuring, coordinating, and stuff to get a thermal glue that would have enough thermal conductivity to pass the heat onto the heat pipes, which would then go into the lid of the unit. That was kind of the whole design, instead of having active cooling with water to do passive
Here we are
cooling.
with the Natick Mini and it's inside here, just booted on. I'm gonna test out how it's doing thermally. I've still got it upside down because the glue is still drying and I want to give it the most time. But I've got booted screen. I'm so psyched. This is exciting. All right, so I've played one round of Fortnite with my friends, and now we're
So here we are just kind of running thermal tests. It's performed pretty well. This Nook is pretty beefy, so it does do things like Fortnite fairly well. And yeah, I was really happy with sort of how it was doing, and then it was just a matter of getting the pressure test.
This is the Natick Mini pressure test.
Nice. So behind the pressure gauge, you can kind of see the bulkheads.
All right, there was our goal, 20 psi.
So we passed those wires through the bulkheads,
holding
and then
pressure.
we kind of sealed it up with epoxy that you can kind of see there. And so that's the final design there for the Natick Mini. And in this exercise, we did fill it up with regular air, and I imagine if you have access to nitrogen, it would be very, very easy to do something like that. Well, guys, thanks for joining on this little adventure. And if you ever try building a nitrogen PC, I hope you learned from this. You know, there's probably some things I could do even better if I were to do this over again. But I think for a first attempt, it wasn't too bad. Who knows what the future might hold? Nitrogen is such an exciting gas that I really think there could be some cool designs in the future for this type of technology. Take care, guys. Andrew Olson signing out.